All right, so it's 11 o'clock, time to start for the first session of the conference. Today I'm going to be talking about how you can use how to connect Hyperledger Besu data to your enterprise systems. Bit of a background, my name is Danno Ferrin. I am a blockchain protocol engineer at ConsenSys. There's a business group inside of it called Pegasus. Sometimes you'll see us use both. Pegasus is the protocol engineering group in systems. Pegasus, someone really wanted to spell Pegasus, and it's awesome, so we do it that way. I've been with ConsenSys for about a year and a half now. I spent a lot of time in the enterprise space and the desktop Java space, and I got kind of obsessed with blockchain back in 2014. And here I am. I'm a blockchain protocol engineer working on one of the core clients for Ethereum. Is everyone here familiar with Hyperledger Besu and Ethereum? We'll do some background with it as we go on. But as I go through this talk, if you have any questions about what's on the slide, feel free to raise your hand. I'll repeat the questions. I'm not big for holding the questions to the end unless they have nothing to do with any of my slides. That's the best time to ask those. But if you have a question about what's on the screen, feel free to raise a question. So the agenda, first I'm going to give a brief overview of Ethereum, and that is going to be focused specifically on what's relevant for enterprise integration. I'm not going to cover everything about Ethereum. And then we're going to have a little brief discussion about the hierarchy of integrations, kind of do a Maslow's hierarchy of what sort of integrations you want, and where you should start from the bottom and build towards the top. Then I'm going to talk about the four different main ways we're going to do integration through JSON-RPC, WebSockets, GraphQL, and through something we just released in Besu 1.4, Besu plugins. And I'm going to have a sidebar in there about how you would need to build your smart contracts for integration. It really works best if the smart contracts are designed to be integrated into the enterprise systems, in addition to be able to get the data from the enterprise systems. So this lovely little hierarchy block diagram is a very vastly oversimplified overview of what Ethereum is. The Ethereum blockchain is a chain of blocks, as the name describes. And each block contains one or more transactions, typically. These transactions manipulate data in the Ethereum blockchain. Each account that does a transaction has a balance of Ether, or whatever the native token currency is on your enterprise chain, if you have it. Each account also has storage. It stores data associated with the code that it executes. We call these codes smart contracts. Some people love the names, some people hate the names, but I'm just going to call them smart contracts because that is the industry standard for what these things are. And finally, another thing that happens while these smart contracts are executed is a number of event logs come out. These are the transaction event logs. They are emitted. Solidity has a keyword, and it's embedded into their language to emit, hey, I did this. These are associated with the transaction. They don't go in the storage. When you look at the transaction, you get the data from it. Now, the first block shows a very simple form of a transaction. There's just two plain transactions at the base of the block. The second block shows something else that's interesting, and I think a very powerful feature of Ethereum. You can compose smart contract calls. You can have one smart contract call another smart contract, as though it's yourself or as though it's them. And so from one contract execution, you can invoke an entire chain of contracts to do all sorts of amazing things. Ask Fulcrum how that went a couple weeks ago with their smart contract platform. It was a work of art, and sometimes the best artists steal, unfortunately. So as far as transactions, a transaction is the main thing that gets put in all of these blocks. And transactions do one of two things. They either call code that is in an account, or they put code into an account. They call the contracts, or they put the contracts on the chain. And that's one important thing about Ethereum. All smart contracts live as data on the blockchain. So you can see every contract that's being executed, and all nodes use that data to verify that the blocks execute. Everything is deterministic and verifiable. So that was one of the key things about the contracts is everything is on the chain, and everyone can take it and execute it in a container called the Ethereum virtual machine. The accounts also are an important thing that execute these, and there's 4 key pieces of data, sometimes 3, that are stored in each account. If it's a public network, there is going to be a value or a balance. The Ethereum mainnet, that value is called Ethereum. There is a series of test nets that they call, Rinkeby Ethereum, Ropsten Ethereum, Go Ethereum for the Goerli chain. And those are the main anti-abuse mechanisms that are used to meter the use on the public chains. Private chains, you may or may not use these values or balance. It's up to you. The next thing is the notes. Has this account been executed? How many times? Is this sequence to make sure you're doing everything in order? And the storage of the accounts, these smart contracts, they will associate a large amount of storage if you're doing like a bunch of CryptoKitties. They need to know in that storage which account owns which CryptoKitties and what the characteristics are. And those are stored in the storage that's associated with each and every account. And finally, if this transaction is a smart contract itself, it will have the code for the smart contract. If it's a regular old account controlled by a public key, it probably won't have the storage. Now, the account addresses that you see in Ethereum are these big long strings, and they correspond to one of two things. Either the public key used to validate that I want this account to do this action, or it has the, it's an address that is derived from the creation of the smart contract that is stored onto that to the address. So some accounts can be executed via public-private keys, and some can only be executed via contract calls. So that's the basis of Ethereum that we need to know to get the data out of the Ethereum blockchain into our enterprise systems. So how do we do it? What's the important things? This is kind of a Maslow's hierarchy of what's important for enterprise integrations, of the sorts of things that you might want to do. And the very lowest thing that you would want to do for any enterprise integration is you want to be able to read from the chain. That is most of what the integrations I'm going to talk about later do, is to give you ways to read data from the chain. Just read what has been done, what have other people done with it, and get that into your other system to report it, to reconcile it, to share it, to do whatever is needed to be done with it. The next level is to write to the chain. There are a couple of methods that I'll point out in here that you can use to write data from the chain. This is another level of integration. There's no point in writing if you can't read from it for an enterprise integration. Sometimes you want to push data back in. The next two levels, I'm not really going to discuss in this. These are kind of the higher level things, maybe in next year's talk. There's some great opportunities for the roles of smart contracts. The next level, too, I call querying, where the blockchain code itself knows about the enterprise system, and all the systems have what is needed for those enterprise systems, and they go out and they call to those enterprise systems. Those require some pre-compiled contract integrations, but it's kind of tricky because when you do the same call with the same value, it has to come back with the same results. So that's a little bit of a higher level. And then finally, there is the highest level, the pinnacle of the pyramid, where you look, act, and smell like just another Ethereum node. I don't think we're there yet, but that is where we need to get with integrating these systems. But to get to those higher levels, we need to work on the lower levels, which is we need to be able to read and to write to the Ethereum blockchain and to get our data from there and to send it out. So, any questions before I go on into the technical hows? Great. Like I said, if you have any questions, shoot up a hand and I can answer it. So for a lot of people that are integrating with Ethereum blockchains, 95% of the time it is done through a protocol called JSON-RPC. This is an RPC mechanism that uses JSON objects sent typically via HTTP back and forth. There is an actual Ethereum improvement protocol standard for this. This is kind of the standard process for Ethereum is to do something called EIPs. EIP 1474 that defines for each node what JSON-RPC calls they're expected to be able to respond to. A lot of nodes go above and beyond what is required in there and implement more features, usually for node-specific features. But the ones that I'm going to describe in the next few slides are specifically for everyone that implements JSON-RPC. Now, JSON-RPC, the integration, there's integration libraries for the JSON-RPC itself in just about every language. I didn't bother to look to see which specific languages to enumerate the libraries, because for my next bullet point, you're probably not going to want to go straight with JSON-RPC unless you have serious performance considerations. If you don't have serious performance considerations, there are many great libraries that don't just wrap the JSON-RPC, they wrap the APIs into language-native integrations. Web3j is one that I've used in Java. It takes all this JSON-RPC and all this connection and drops it into plain old Java code. That's what the demos that I've written have been written in. Another very popular one is Web3.js. A lot of those dApps like CryptoKitties and a lot of the decentralized exchanges that are all web-based, they use the JavaScript version of the integrations of typically Web3.js. There is Ether.js. There's a lot of different versions of this. The most common one is, of course, Web3.js. And it targets JavaScript and Node on the server side. So you can use it in your web browser and you can use it on your Node.js backend. There's a couple more just to show that I picked two random languages that I thought people might be interested in. And integrations exist for these languages. ETH-RPC is an implementation in the Go programming language, and it provides the same level of integration of a language native integration. It looks like you're just calling another Go object. Once you set up the connection to the server, it works just fine. And another one is Ethereum RPC client in Python. The URL is longer, so I had to drop the font. Sorry about that. But this is something that is maintained by Piper Merriam, who is, a very highly respected person in the Ethereum Python community. He's leading the stateless Ethereum effort. So he's written some very good integrations if you want to connect via Python. Python is an important growing language in a lot of business backends. So here's a quick look of what a JSON-RPC wire protocol request looks like. It's really simple. Here's the method, here's the parameters, and this ID is used to multiplex in case you want to do multiple calls and not have to wait for the results. So we want to know the get balance of this particular query. It comes back that your balance is 1CFE, some big, long 18-digit number. It's in hexadecimal. So the languages also deal with a lot of the weird edge cases for a lot of the details, like most things that go over the wire protocol need to be in hexadecimal. You use language bindings, doesn't matter. You just need to know that ETH get balance is what you do to get the balance. So probably the top 5 methods you're going to use out of JSON-RPC to get the data off of the blockchain into your enterprise system are these. ETH get balance is the one that you're probably not going to be using that much unless you have your enterprise chain uses balance. Get logs is a very important one because you're going to get a lot of the log events that are going to come out for a lot of the contracts you execute. ETH get storage app gives you access into the actual storage of the account. So you can give a slot number and you can get the data directly from the smart contract storage without having to interface with its methods. You can just poke at it. If you know where to poke, you can read the data. It's all in the public. Now, as I mentioned that you might not know what the storage to get at, there is also something called ETH call that allows you to execute view or static methods in your Solidity contracts. You may have more convenient ways to get the data. And per one of the bullet points, one of the reasons why you might want to call that is because you can't enumerate all of the fields that are in the storage just by the get storage at call. So if you want to be able to do a full enumeration of all the accounts in there, you're going to need to integrate that into your smart contract and have it accessed via an ETH call method. But it can also provide other metadata, such as what is the name of this token? What is the trading symbol of this token? How much of this token is out there? It's great metadata that you can do, and also you can do some small level of data analysis. And finally, the last thing is you can query a transaction receipt. Sometimes you need to know if a transaction succeeded and failed, and that's really the only way that you can get at that information. So I'm going to take a quick sidebar and talk briefly about building for integration. These APIs are great. They're low level, they get you all the details, but it's a lot of work sometimes to get this information out. You need to build your Solidity contracts with a little bit higher level information to get the information you need. The first thing you should do is use something called view methods to simplify some of your interactions. If you have multiple maps that you store multiple values of the accounts, people may not know directly what the hash values you need to put in to get at those. So if you build a view method, then the Solidity contract will be able to get that information for you. If you have transient information that you don't need to store forever, use a log event. Storage can be expensive in Ethereum on a private chain and especially on the public chains. So if it's something that you only need to query once, put it in the transaction log event and have your integration pull that information from the transaction and put it in your enterprise system. Finally, you can use a Solidity ABI to decode the data that you put on in these data segments. There's a very well-defined format in these languages that I pointed out earlier. We'll show you how to bring that data out and put it in directly. One very good example is the ERC20 tokens. This is one of the oldest Ethereum standards out there that's used widely, and it's how you deal with fungible tokens. That's how I think Tether, the Ethereum version of Tether, implements these ERC20 interfaces. If you poke at the right contract for DAI at Maker, at a certain level, they are just ERC20 contracts. And they expose all these events. They have these view APIs. And when you get into some of the log data, you use the same APIs to decode them. ERC20s are the poster child for good integration. ERC721, kind of like ERC720. These are the non-fungible tokens. They provide really good integration. Any questions on What's been mentioned so far? So JSON-RPC is probably the most typical format you're going to use. Another option is WebSockets. WebSockets provide the same JSON-RPC calls over a persistent connection. That ID number you saw in there, you can sling a bunch of them out, and the other end will return them in the order that they complete in. You just need to match up the IDs, so you can just keep pipelining all this data in. But it also exposes four more calls that are very useful when you have a persistent connection. You can ask it for, tell me when certain kinds of logs come in, tell me when the new pending transactions, I'll come back to a little bit later, logs and syncing. But mostly logs, you can say, I'm going to listen for logs for this contract, for this particular event, and it'll just push it into your system as long as you're listening to it via the API. The WebSockets also exposes a few different, a few more streaming things. The syncing one, actually there is a JSON-RPC method for that. But the two other things that are interesting to read from the WebSockets API are the new pending transactions and new heads. I haven't really talked about those in any of the other integrations, but they give you insight into the state of the blockchain itself. New pending transactions, Ethereum runs what's called a memory pool. So all of the transactions that come in from the world flow in, and until they're put in a block, they just sit in each node's memory pools. When a new transaction comes in that hasn't been committed to a block, you get that via the new pending transactions call. So if someone broadcasts a new transaction, you know that it's coming, you can be prepared for it. And sometimes what's interesting is sometimes these transactions don't actually hit the blockchain because they get replaced or they get dropped. So this might be interesting to know in enterprise integration if someone's trying to do a transaction that gets canceled. Very interesting for the auditors, very interesting for the people doing a lot of the regulation for this. And the other one is new heads, and that's when a new block comes in. So when your ConsenSys algorithm produces a new block via committee, or whether it's mined via a proof of work mechanism, this will tell you when that block comes in. If you're using a non-proof of work mechanism, you can poll at a regular interval and be pretty close to guessing when it's going to come at. But if you're using a proof of work or working on a mainnet, those blocks come in at essentially random times. They average at a certain time, but they can be 5 seconds, they can be 50 seconds apart. By subscribing to WebSockets API, you insulate yourself from a lot of those changes. Yes?
Hi. Can you tell me more about the cancellation of transaction? Is that initiated by the application or no? It's because of the forks and conversions and stuff like that?
So sometimes transactions can be canceled because someone posted another transaction with the same notes. So I actually ran into this a few weeks ago. I was trying to post something to XDAI, and I accidentally set the gas to 0. And that transaction is never going to get mined. And if you don't, and there was a bug in MetaMask at the time that it couldn't replace that transaction. So anyway, I got it fixed. And what I needed to do is I needed to post another transaction with the notes at 0 to get it mined so that my transactions at 1, 2, 3, and 4 could get mined. So sometimes you might do it to fix a mistake that got your transaction stuck in the memory pool. Another time is it might be because you haven't paid enough gas and it's not going to get mined in a reasonable time. So you might post the same transaction with a lot more gas. If you are a bad actor and you made a mistake and you linked 2 accounts, you're going to send a replacement transaction that ruins that linkage, so those don't get committed to the blockchain. So there's good reasons to do it, and I've actually seen that exact scenario I described where a nefarious actor accidentally connected themselves in the memory pool, and they cut it out, and they put in a different transaction to get them together. So that's why I mentioned that regulators might be interested to know what's in the pending pool. It's just some really crazy things that go on. It doesn't happen that often, but when it does, it always tells a story. So when I started out in blockchain, I was doing Bitcoin forensics, and it was quite the Wild West in 2015, 2014. Any other questions? Great question. And I lost here we go. So the third native protocol integration that's recently come into Ethereum is GraphQL. For people who do much web development, this is going to be exciting to a lot of people. The big thing that GraphQL gets you over JSON-RPC or WebSockets is you can do bulk queries. Let's say you need to get 1,000 log entries from 1,000 different transactions. Or you need to get 1,000 different transactions in the memory of those. In JSON-RPC, that would be like 1,000 different calls, and you get the overhead of starting up the HTTP transaction, of putting in the JSON-RPC, of encoding it and decoding it 1,000 different times just to do that one call. With GraphQL, you can structure the call to say, give me from this range, and I do one HTTP transaction, and I do all 1,000 queries in there, and it comes back all in one bulk query. That is the biggest advantage GraphQL has. It also allows you to say, I only want these fields, and I don't want the rest of the data. I only want to know the storage field. I don't care about the balance. I don't care about the notes. I don't care about anything else that's coming in the transaction. It gets at the same data that you can get at in JSON-RPC. All the same access paths are there to help you get at the query data. One downside right now is there is no way to do static calls in GraphQL, but that's something that could easily be fixed in the Ethereum improvement protocol process. If people found a value for it within GraphQL. Generally, though, you're not going to be doing bulk calls. You're going to be doing onesie, twosie. So JSON-RPC, you don't get much more by going for GraphQL for those static calls to query your contracts. Here's an example of how a GraphQL log looks, a GraphQL query looks. In this case, we're just querying one log because I don't want to use tiny font on the slide. So we do a logs call. We want to go from block 2.2 million to 2.2 million with these specific topics. And this specific topic happens to be the ERC20 transfer topic name. The ABI encoding tools will get this into the hash, and they love to talk about 256. It masks it for you typically, but this is what it looks like on the wire. And then I want to know the topics and the data associated with that log. I don't need to know the address. I don't need to know who it's from. I don't need to know the block that it's in. I don't need to know all the extra metadata. I just want to know what the topics for this call were and what the data were. So in this case, a lot of the data is lighted out, but this was a minting transaction because this field corresponds to who it's from, and if it comes from 0, we create it, and this is who it goes to, and this is how much data. Because I lighted it, a lot of the value went out away from it because, again, I didn't want any tiny font. But you see these brackets here. This is a JavaScript array. So we could have, in these logs, from this query, if we did from 2.2 million to 2.3 million, we could get megabytes of data just from one query, rather than doing thousands of different JSON-RPC queries to get at the data. Here's another example. In this case, we're poking into the account storage. And we query the storage twice for the same account, poking at slot 5 and then some random slot that corresponds to the data. This corresponds to the previous transaction that I showed, getting all the data out of where that particular transfer occurred. And here you see in the query results, you get the balance, and we use a GraphQL facility to rename the fields so they don't collide. So 5 and map, and it shows up. And we only get the data that we need from this query, which is something that you don't get out of JSON-RPC. The final feature I want to talk about, and this is unique to Hyperledger Besu, we just released it last week with the release of Besu 1.4, is the notion of Besu plugins. Now what plugins are, is these are Java programs or Java jars that you put directly into your node. And as your node runs, it's going to interact with the Besu node. One of the pillar features that we have of those plugins is it has access to the same data that the JSON-RPC APIs can get at to read. You can also do things like you could replace the storage engine. If you don't want to use RocksDB and you want to spend the time writing a Postgres integration, you could do that and integrate that via the plugins. And there was a third pillar that escaped my mind. I think it was metrics. Anyway, there's a webinar that I go through this. I had this all memorized about a week ago. But the key thing about the plugins is they're in the Besu node, and they respond to the data as it comes in. There is no polling that needs to go on. They give you the data, and you push it right out to your enterprise systems immediately in process. And that's the big value is it's all push-based. Now, one of the things when I was preparing my webinar a couple weeks ago, the webinar right there, something we did for Pegasus to explain all the fun details you can do with plugins. But as I was creating the demo and researching it and trying to make sure I didn't break an API, I stumbled across 41 North's Xflow plugin. We had the plugin data. We hadn't publicly announced it. It had been coming in the 138 and 137 stuff. These people had found that code, and they had actually written an enterprise integration plugin without any help from us, without any quality documentation. They're able to read the APIs, and they literally can extract things into Kafka and PostgreSQL databases directly without us, without, you know, I was just amazed when I found that. It's like, wow. So that was a wonderful surprise. So stuff like this is in the wild, and it's being used to push data into these systems. And if you want to learn how to write your own plugins, watch the webinar. There's a little toy plugin that I wrote that's going to take, it's going to publish events for the gas usage, which not very enterprisey, it's more mainnet-y, but it's going to calculate it and expose it as a Prometheus metric. Any questions before I go into the demos? Great. So in this demo, I'm going to show how I pull out the ERC20 events. And because we're talking about how to pull it out of the blockchain for the enterprise integration, I'm going to use an incredibly simple enterprise integration console output. So if you can get stuff to console output in the data, you can get it to your own database. You can get it to your own Kafka event stream. You can get it anywhere that you need. So these demos just show the part of getting it off of Besu into the data that you could then integrate. And what we're going to pull out is we're going to pull out ERC20 events. There's two that are worth noting. There's the transfer, where I'm transferring from an account to another account. And then there's the approval, where you approve someone to spend money on your behalf. The pull is via Web3j, both WebSockets and JSON-RPC, and the push is going to be through Besu plugins. And I have a link here that I just published the code this morning for my demos. So we're going to see what goes on with that. So let's go to the demo screen. Now, as I mentioned, this is using Web3j to do the integration. This is Web3 Labs out of Europe, some European country in the EU that they wrote all this. It's really nice stuff. Evalio, I think, is one of the authors of this. He's one of the committers in Besu. And this is a very simple integration showing how all you need to do is point it at the endpoint. And here we're going to get the block number in the request. And it uses reactive RX, you know, some really fancy programming stuff to do flowables. As these data comes in, we just log the events. So it produces, you know, we get the event logs. It produces a nice formatted object, a log object that wraps around all the complex wire protocol stuff so that you don't have to worry about it. We look to see if the protocol, we get the value of the token, the symbol, and the address. And here, we're actually querying the ERC20 contract. So create an object representing the specific ERC20 contract that we've learned about from the events, and we ask for its name and its symbol. Then we get the from address and the to address, and then we print it out. So let me make sure that my node is running. Indeed it is. And let me go to the JSON-RPC demo and zoom in. So we run this integration. And this is the nervous part as I'm running this against Goerli. I don't know if there's going to be anything interesting in the last 10 blocks. So this is going to run against the last 10 blocks. See if there's, yes, there is. We got lucky. There's actually some interesting stuff that happened in the last 10 blocks. Test token sent several things. And so one of the things I integrated in here, we got Splunk in the room. They did a recent integration with Ethereum into their work. And one of the things they did is they had a list of every single possible smart contract event that they could divine from the source code. And I was able to take that information, plug it in, and when we look at these contracts, I was able to reverse engineer out what some of these random names were. So we can see the channel new deposit. I don't know what this contract is, but it's doing something interesting. But if I was listening for test token, I know that this is a deposit going from one place to the other with a value of 555. Again, Goerli is a test network, and there is a conference going on in Paris right now. So I'm sure they're doing a lot of tests and a lot of demonstrations for a lot of these random test tokens. So we could monitor this. You know, they're in Paris. We're a regulator. We're just reading their tokens, seeing where they're going and seeing what they're doing. Or I'm an auditor for my own company. So the next demo is WebSockets, and it's a lot of the same stuff, just done with a different way to run it. We have a different URL to WebSockets. We connect a little bit differently. And the log events is mostly the same. We get the event from the WebSocket. We run the same queries to get at the data. Let me minimize this. And we print out the same results of the information. So this WebSockets, of course, because I've been up and down on the Wi-Fi networks, has stopped working because it's a persistent connection. But as I turn this on, it's going to start getting results as the blocks roll in, which is kind of every 15 seconds. So we'll leave this here on this screen while I briefly talk about the Besu plugin. And the Besu plugin is another format, is the final thing. And this is copied from my demo thing. We create a service that's going to be put into the jar with the plugin. We register it. And we just register the Besu events. And we register the start events method will be called on the Besu service. So when we start the events, we add an event log listener. We're going to listen to just the transfer API. And when we get it, we run our log event method. So when we get that, we do the transfer ID bytes. And we do the same sort of an integration on the back end here. And this has been running for a bit more stable. Had to restart it because of, the wireless network connections. This has been running on the back end. If I were to stop this for about 10 minutes, one of the cool things, if I stop this and I bring it back up, as the data comes in, it's going to roll, as it's syncing to the blockchain, it's going to get all that data as part of the plugin. Getting that startup window from when you bring up a node and it's catching up to the end can be tricky if you're doing just querying, trying to get stuff as it's coming in. So if you do a poll-based integration, you're going to need to make sure that you cover the blocks that are in there. Or you could rely on a push-based situation like it's going on with the plugins to make sure you get pushed all the data that is brand new. Now I am connected to the network, right? Gotta love demos. The one time that I need a bunch of transactions to come through, they stop doing them. So that's the demo. That's the how-to of how you can get your data off of a Besu blockchain into your enterprise systems. Are there any questions that I can answer? Any burning things that I didn't cover that you wanted to have covered? Are there what? Are there upgrades? Other languages? Yes. Yes, there are other languages. This demo was written in Java because it was the easiest one for me to get at the time. You can do these exact same integrations. Well, you can't do the plugin integration. There we go, a block just came in the plugin. You can't do the plugin integration in Java, right, in anything but Java. But the JSON-RPC and the WebSockets, you can use JavaScript. You can use Go. You can use C++. You can use Python. There are other language bindings for these. Huh? It's kind of far across the room. I have a microphone here. Is this microphone turn on? Okay, you got it? Yeah. So we do have, different integrations. These are the particular libraries. There's all sorts of different integrations out there that you could run with this. Yes, there is. Reiser and Steve Schroeder are specifically working on that right now. At least Steven is going to be in Paris. They're having a stateless Ethereum summit this coming up weekend. That is something we're very interested in. For people unfamiliar with BeamSync, it's a technique that allows you to validate nodes on the blockchain without needing to have either the full head of the memory, which is you need about 200 gigs to do that, 200 to 300 gigs, depending upon your system, or the full history, which I think is up to 3 terabytes. And it takes hours to sync up. With BeamSync, you can get synced in about 15 seconds, I think is what their demo was, is what Nethermind did. You're not syncing up the whole blockchain, but you're just getting enough data to prove that the block you just received has all the data it needs. And it's leading a bigger effort in Ethereum called stateless Ethereum, which is how they're really trying to address the state bloat issue. Right now, to run an Ethereum node, you need to have at least the current head block state of everything to assemble something called the state tree. You need to hash up all the state values. You need to build some Patricia tree, and it takes a lot of data to produce that. So what they're producing with that is something called witnesses. So each block will come with a witness, and it'll have all the data that you need to execute it and all of the sibling data that you need to build the tree. So you don't need to know all those abandoned ICOs balances to do a fast beam sync or a stateless Ethereum sync. You just need to know, as you go up the tree, what those particular values were to finish off your witness. And for people unfamiliar with the cryptography, the way that Ethereum builds its state is a variation of a Merkle tree or Patricia tree, where you push things down to a certain level, and then you hash 2 of them together, or 16 of them together, depending upon whether it's a Merkle or Patricia. And then you go up another level, and you hash 16 of them. And you go up another level, and you come up with one number. And with that hashing along the tree, you don't need to know the entire depth of the branches of all the ends. You just need to know the data of where that tree joins to produce that hash. And that's how they can produce that really skinny, stateless tree of about kilobytes to prove a block instead of gigabytes. So that's something I'm really excited about, and hope we have good news about that by the end of the year.
So I'll be the dummy, maybe just the only one who didn't understand, but what's the main advantage of the plugin versus using JSON-RPC? Because at the end of your demo, you do the same. So
right.
Why should I use a plugin instead?
One less process. So it runs in the node process. If you're doing JSON-RPC, you need to stand up the node. Performance, you get a performance gain. It's a lot closer to there as well. It's push-based. With a separate process, you need to pull, you need to query it, or you need to set up a stateless WebSocket connection and hope that you got all the data. So the real advantage of doing it in the plugin is you get rid of another process, you get rid of another thing you have to monitor and make sure it's connected, make sure it's set up, and brings it into the process, and you can push it out. So that's only one of the 3 pillars of the plugins things. Another thing we're letting people do with plugins. We've started with the database. You can replace the database if you can provide all the APIs. We have a product that does that for encrypted databases. If you're really into encrypted data at rest, we have an example of that actually working. There's other databases we're looking at for performance reasons that have different trade-offs. Yahoo's got one, or Oath is their name, called HaloDB, that keeps the index in memory. And if you can get 200 gigabytes of memory on your system and it's important to you for trading, it's an incredibly fast database. But I don't know many people at home that have 200 gigabytes sitting on their VR rig. So that's some of the things that the plugins gives you, is more options to change out some of these pieces, parts. Looking way down the horizon, I could totally see us using the plugin API to put in different execution environments. If there's a standardized WASM sort of execution environment, we could put in stuff for that. If we need new specialized precompile contracts, you could use a plugin to put in those precompiled contracts, kind of like my querying level of the hierarchy. If you want to query from a newsfeed and you have to go to the network, you could wrap that up in a precompiled contract. Those are the sorts of things that the plugin enables, is getting more advanced features into the nodes. And we just started with plugins, just started exploring with all the features, because we don't really believe that a single node is going to be one size fits all. It's going to need to have some mechanism for customization. And plugins is our vision for providing that customization. I believe we're at time, right? So I'll be here today and tomorrow, definitely. We'll see how the news breaks out to see if I'm here for Friday. But you never know. But thanks for coming.